I'm going to show you how to model historical interest rates from the web. First of all, we have to go ahead and locate where those historical mortgage rate curves are located. So I just went to Google and notice I just typed in historic mortgage rates or historical mortgage rates, which pretty much get you the same results. So the one we're going to select is this interest rate trends, historical graphs for mortgage rates. It's from a website called mortgage-x.com/trends, and the reason I like this one is because it shows you the different graphs as well as the different types of mortgage plans available. So we're going to go ahead and take a look at that one, and so you'll notice that the first thing it gives you is you got to be careful about reading these graphs to tell you how far back these go. These are the 3-month trends, and you'll notice that it has everything from 30-year fixed rate mortgage, 5/1 ARM, 15-year fixed rate mortgage, and 1-year ARM. Since we're focusing in this part on the 5/1 ARM, we'll want to use the 5/1 ARM curve, which appears to be this one here. So this is the 3-month, and then down here as you get lower, you'll notice this is a 1-year trend and 3-year trends, and you can go back all the way, I think, 1971 to 2010 to sort of look at interest rates. I'm going to leave this up to you. I don't want you to copy exactly what I'm doing. I want you to be able to justify how and why you decided to pick the period of interest rates to model that you did. So you may say, well, I only want to look at the 3-month trend, and so of course you'll want to back up your justification of that with some evidence why you believe that. So notice it'll be a little bit easier to collect data points here. Now they don't need to be exact, so you can even come over here and say, oh well, this point looks to be about halfway between 4 and 4.5, so I'm going to guess that's about 4.25. So you can kind of do some guessing on these guys if you choose to go back farther. Again, how far, whether you want to just do every October or every January, is totally up to you, and I encourage you to get creative with it and think critically about it. So next thing we're going to do is pull these things into Excel. So I think the only way to really go about this, unless you can find a way to download these graphs and the data in some sort of text format, which I don't think you can do, you're pretty much going to need to type them in. So what I've done here is just created a quick little setup to give you an example. Notice that I have the years 2006 to 2011. This was very just arbitrary and random. But for the actual years that I'm going to model in terms of ordered pairs, I'm going to use 0 to be my beginning year, 1 to be the next year, 2 to be 2008, and so on, because otherwise you get really ugly looking equations. Because remember, calculator doesn't interpret 2006 as the year, it interprets it as the number 2006. So notice that here's the data I'm using, then I plugged in the rates down here, and now I'm ready to model these. So what I'm going to do is just go ahead and highlight all of the including the labels on the rows, year and rate, and then the corresponding year numbers and rate numbers. Now these are totally made up, these are falsified. I did not do any research. I think I just randomly picked some values just so I had an example to show you. So I don't want to take away your fun. We'll do insert. Next we'll go over to scatter, and we'll want to select the dotted scatter plot so we can visualize. A guy named John Tukey, famous statistician, always said, plot the data, plot the data, plot the data. So you can never do anything better until you've plotted the data to take a look at trends. Okay, well next I want to decide, well, what's happening to the data? Well, from this appears to be going down. Obviously it's not going to go down forever, so I want to reflect that in the type of regression that I choose. Under chart tools, you'll want to select layout, then the trend line bar over here under the analysis heading, and we'll go straight down to more trend line options. We'll select that, and I'm going to scoot this box over just so I can see my graph because things are going to change real time. The first thing I want to make sure that I have is these down here. You want to make sure you display the equation on the chart. So you want to check that box, and you'll notice that the equation for that particular selected trend line, right now we have linear selected, the best fitting line equation is down there. Now we'll also want to display the R-squared, and if you'll recall, R-squared is basically the strength of fit. Statistically speaking, it means how much of the fluctuation in the data is accounted for and explained by the data itself. So I like to think about this at a very simple level as this is about a 98, this curve slash line receives a 98% as a grade, so it receives an A+ for the strength of fit. So you might say, okay, well, let's select it since the r squared is so high. Now this is going to be between 0 and 1, much like your grade on a test or a quiz or a project. It's going to be between 0% and 100%. The closer it is to 0, the worse the fit. The closer it is to 1, the better the fit. Now the problem here, oh, by the way, if you ever unselect the line, you've got to make sure that the line's highlighted. Otherwise, you're going to jump to some other screen on here. I also want to think about long term. Now, you know that linear, this has a constant rate of change, and it's going to be constantly decreasing, and that may not actually be what we believe is going to happen. So I can select some of these other guys, like exponential. I can do polynomial. Now, polynomial, order 2 means a quadratic function. It may not look like a quadratic function at first, just because we're, you know, it's just a very small set of data points. And as we change these, we're changing, you know, from a cubic to a quartic to a quintic, etc. But don't just select the one that looks to be like this one fits all the data points exactly, 100% fit. However, you know, it also has some explanations that we would need to commit to. So is this really important to keep all these little jags and curves intact? Probably not. But more importantly, what is this predicting in the long run? Well, this guy is going to end up curving back upwards as it looks, and so do we believe rates are going to go up in the future? That's where I want you to do some research. Decide for yourself, do we believe rates are going to go up? If you do logarithmic, you're going to notice that you get an error. That's because the logarithmic function does not do, logarithmic regression does not do well with inputs of 0. So one way I found to get around that is to trick the computer a little bit and change the year to 0.000001. So it's super close, but it's not quite exact, and so you are able to get a logarithmic equation that way, which in this case this looks pretty bad. But again, don't just think about connecting the dots. Think about how well it models the trend, which is more important. If you ever decide to change your equation, make sure you click on the line or equation that you have in there now in your graph. Otherwise, if you go back to layout, more trend lines, it's going to incorporate a second one in addition to the first curve, so it's just going to get really messy. Then you can do a power. You can do, well, moving average, you can't really do anything with that because there's not a function to describe it. So you basically have a few choices here. Now, polynomial, remember, you can make that a quadratic or a cubic, you know, depending on what you feel fits the best and predicts into the future the best. So I'm going to just play somewhat naive here and say, well, I believe it's linear. I believe that the rates are going to go down, and so I'm going to stick with this one. So I'm going to close it. And now I want to predict interest rates. So I already know that in 2011, according to this data, it'll be a 2.78% interest rate for a 5/1 arm. Okay? Well, now I want to predict, because this is a 5/1 arm, I know it's going to reset in 2016. Well, 2016 is going to be equals this, oops, take that back, equals this minus 2006, so that's 10 years after 2006. And I'm going to use this equation down here to help me predict what I believe the rate will be at that time. So I'm going to do negative equals negative 0.4312 times, you got to do the multiplication sign in Excel. You can still use parentheses, but you got to put in a multiplication sign. And now I'm going to do the input value, which is this 10 up here, close the parentheses, plus 4.9983. Now when I hit enter, it produces an output. So this guy actually says that in that many years, in 5 years, according to this, according to the data, in 5 years, the interest rate is going to be at 0.6863%. Which, you know, this is where we start to run into practical issues. Does this make sense? And we would do the same thing for 2017, since this is a 5/1 arm. Now it's going to reset every 1 year. So I'll do equals this plus 1, oops, equals this plus 1, and I can kind of drag this over and do this for all the other years. So now I'd have 11, 12, 13, 14, etc. And now the cool thing is that I can actually copy this equation and paste it over to the next cell. So Excel is smart enough to realize patterns that you're referencing the cell directly above it. So when you copy and paste that, it's going to again reference the cell directly above it. So anyway, once you have this all done for all of the years, now of course this is, like I said, it's getting ridiculous because now we're starting to get into negative rates, which absolutely don't make sense. But now I have my rates. So this is my data set. So what I'm going to do is just move these aside. You don't need to do this, but just to kind of show you, to keep your focus on the data. I'll say equal this. And now what I have is now I see the actual rates that I'm predicting for the future. Here's where I get to use my 525 cap knowledge. Well, if it starts at 2.78, and let's say in reality this thing we predicted that it was going to go up to, let's say, according to our equation it went to 5%, well, now we can decide, okay, is that adjustment going to take place? Does it meet our initial cap? Does it meet our lifetime cap? And so the point is, this equation will allow us to actually get the rates, what we believe they will be in 5 years, and then every 1 year after that. So that's pretty much all there is to it. If you have any questions, please let me know, and I'll be happy to post more of a video, but this is really the basics to modeling interest rates.